Okay, so there's another long session, 2-break day. This should be the last 2-break day as far as the plan for the semester. This was the last day where there was this so much content that we couldn't really hit a good stopping point until after all that. But for the rest of the semester, it should be like 1-break days, and then we'll have lots of lab time to go practice these concepts afterwards. But well, that's what we need to do is kind of walk through an example. We went through the concepts of a selection structure. We can have the computer can sort of answer yes or no questions for us. Simple mathematical distinctions, bigger, smaller, things like that. So I wanted to walk through an example, which like we saw before, we'll do in Raptor. And with today's example, I'm going to show you a easier way to get from between the flowchart pictures if you're just starting off in programming and the visual representation is helpful. I'll show you an easier way to get over to Python from that for the other type of stuff. I know the first semester when we switched textbooks and started using both languages, a couple people did say they found that easier. They were new to programming, so they thought the flowcharts were helpful in making sense of everything and not skipping steps, taking steps for things for granted. Because when it's in a flowchart, you can see like there's a gap there if you skipped a step or took something for granted. But sometimes it's not so evident in the text-based ones. But there's an easier way to get between the two languages. It'd be nice if we could just go directly and have the computer translate it for us, but it's not on our current list. So for an example, well, I'll bring in this as a good starting point is to always clear the previous output. So I'll come in here and start by clearing the console. And I'll write what we're going to do here. So I'm thinking a good example is what grade did somebody get, right? We're in a classroom setting, so a grade is a good example. So that's our example. Example is what grade did somebody get? So our basic pseudocode, the algorithm of what we're going to do is, well, we need to ask what the score was. Right? Is we get a numerical score, right? Take a quiz, you see, okay, I got a 93 on that quiz, but what grade is it? We use letter grades. So the computer can make those comparisons. It can see where that number falls, whether it's an A, a B, a C, or a D. So first thing we need to do is get an input from the user. So I'll say input, enter the score, something like that. Ask the user for a score, and we'll use that to set a variable called score. Actually, I'm going to do some copy and paste. I'll move that up here. Set score to an input from the user. Pseudocode is a tool for ourselves, right? There's not necessarily a right or wrong. That's the point halfway between English and computer code to help us organize our thoughts. So there might be some adjusting. I thought, well, this might be a better way for how we do it in Raptor. We're going to set a score based off an input we get from the user. And then we can check that. So if, if that score variable is bigger than 90, or exactly 90, because if you all scored exactly 90 and I wrote down a B for the grade, you would probably be very, very angry, right? A 90 counts as an A, 90 to 100 is an A, 80 to 90, a B, and we want to include that first one. So I'll do some indenting here. I'll just push space a few times to help kind of signify that, which is similar to what it would look like in Python. So if the score is bigger than 90, then we'll say grade is an A. Else, if our score is more than an 80, we'll set our grade equal to a B. And I think you all kind of see where that's going now, right? And you'll notice it'll check this. And once it finds the true statement, it doesn't run all of them. It only runs one of them. So if our score was, say, a 93, it's going to set grade, and then it's going to skip over the rest of it because it already knows what grade is. It doesn't need the else part. So by the time we get down to this, we already know it's smaller than 90. So we don't have to do both conditions. We don't have to say bigger than 80 and smaller than 90, because we would never hit this line of code unless we're smaller than 90. Bigger than 90 would have been true already. For pseudocode, I'm just going to write ... because I think y'all see where that pattern's going. And then finally, when we get all the way down, well, I guess I could write it out. It's not much. If it's not bigger than 80, then is score bigger than 70. And if it is, we'll say the grade equal to C. Else if scores at least a 60, it's still a passing grade. But if none of those things are true, we're down to there's nothing else it could be. There's only one grade left. Then we'll have our last grade. I'm going to write end if here to mark the end, kind of mark the end of that. And then we can output the grade. So I'll do it in capital letters. And output the grade is plus whatever we figured out that grade is going to be. And when I hit done, we should be able to see that a little bit better once it saves. So there's the basic algorithm of what we want to write. And that's not the part I was talking about that would be clear, easier to Python. I guess that particular case looks a lot like Python. So that's the plan for the program we want to write. And we've seen some of it. We know how to get input from a user. We can do that with our input box. And throw up a prompt to clearly let the user know what value we're looking for. Enter the score, that'll be enough for here. And we'll store that in a variable called score. A nice meaningful place to keep track of that data. Then we want to do our selection structures. So like we were talking about right before the break, the UML symbol, our standard international symbol for it, is a diamond shape. So that's this one right here, which is also labeled in Raptor, which helps to make that a little easier. Bring that out, and then we'll check this stuff. So the diamond takes the place of the keyword if. So inside of that diamond, we'll ask the question. So what do we want to know? We want to know if score is at least 90. Because if it's at least 90, we're on the yes path. So then we want to set grade to be an A. And we saw how to do that. We bring in an assignment. We'll set grade equal to A. And remember your quote marks, because that's an explicit string of characters, even though it's only one character long. Notice from that picture I drew, things have moved. So we do have to watch out for that. They will move on us. I guess this is a place I could show this. This little symbol here, that's the collapse. So that as the picture gets really big, you can collapse it down and get it out of the way. Then we have to do the else if, right? Which isn't just an abbreviation for, we know the yes one, but the no one leads to another question. And we can build up any layer of these, right? We don't even have to take the no branch. Maybe the user input was too small, so we just make it a bigger number. If user input is less than 0, multiply it by -1 so we get a positive number, and then proceed on with the program. Or in another situation, we could only do something on the no branch and ignore the yes branch. Different combinations of these simple structures. I'm gonna go ahead and do the nesting. So if the answer is no, we'll ask another question. Well, if it's not bigger than 90, if it's smaller than 90, is it at least an 80? Because in that case, our grade would be a B. So I'm going to copy from here and paste that in and just edit this one. Whoops. B. And for copying and pasting, notice when I click on different spots, we get different highlighting here in our flowchart. And handle, like, if I click on this diamond shape, which has been kind of expanded now, it includes what's in those paths. Or if I click on this one, it includes what's in the yes path and the no path, or branches, depending on which terminology makes the most sense to you as far as the picture goes. It includes both of them, so I could highlight that. I clicked up here to get everything in both branches of it, and then do copy and paste. Actually, I'll use the right-click menu. So copy that, and if I come over here and click in the spot where I want it to go, then paste. See, it pasted in a bunch, that whole thing, so we have a bigger section to work with. And you want to copy and paste as much as possible, because computers never make typos. But humans make typos all the time, right? So if we're bigger than 70, means we got a C. If we're bigger than 60, that means we got a D. And we could nest another one in there to check if we're anything else, but we already know if we got down this far, we know it's not bigger than 60, so there's only one grade left. So the else branch sort of serves as a default catch-all. If it's none of those things above, then there's only one grade left it could be. And then I'll, like that pseudocode we put together, and then I'll put that. The grade is plus whatever the computer determined the grade to be. If I zoom out a little, it fits. That might be hard to read on the screen. Hopefully it's not too bad. But you see how we can expand our flowchart? So last week our flowchart just did this, which isn't much of a flow. Now we have some choices. We get this far, instead of going straight down, we can go through and check different things. Maybe we give it a 70, whoops, ignore that mark. Maybe we give it a 72. So if we come down, is it a 90? Nope, not 90. So we take this branch. Is it bigger than 80? Nope. So we'll keep coming over here and asking those questions. Is the score bigger than 70? Which for 72 it would be. Then we take the yes branch And you'll notice here at the bottom of the flow chart, when it comes back together, whoops, I guess comes out here, all of them come back together, and we do the same thing after we found that value. So it gives us more interesting flow to how we move through our flow chart from beginning to end. Does anybody have any questions about that? Hopefully it makes a little more sense seeing it there than all this talking about it beforehand. It's an active subject. We usually learn best by doing.
I accidentally almost made a program like this. I didn't read the question properly last module with the multiplication one. It was kind of a nest figure. It's like if you did multiplication, you did this. And if you did divide, then this.
Yeah, yeah, I've seen it show up a couple times. People try to work it in there. There's lots and lots of places for it. So for that that example you're talking about, it probably would have made more sense as far as making a calculator if we asked the user what they want to do. Do you want to add, divide, subtract, multiply? And then we check that. If the input is equal to add, which is a string, so we'd want quote marks around it. If the input is equal to subtract. And then we have the specific thing that the user requested. My speed's turned way up because I was doing a bunch of grading. Let me turn that down so we can watch it flow through the chart. So it goes through here, asks for the score, maybe an 83. So it checks our first question, then the next one, finds the result, and then gets through it. Does that make sense? You'll see how that gives us different alternatives. It's not just one flow from start to end in our chart. We have multiple branches we can take, and we can keep putting those branches together to build up a complex answer whenever we have a complicated situation. Like, I figured it would be okay to jump ahead and see the simple thing put together. We could, and in any fashion, we could just do a yes thing and not have any no stuff, which would kind of look like that. I'll collapse that and scribble this out. So ignore this part. And we could have something as simple as that, where we do something if it's true, but then we don't do anything else.
Or just like guessing a number.
Yeah. And a question showed up in the chat room. Sorry, that's why I paused there. Yeah, that's fine. There was a question about which direction it went from the previous thing. So as long as it produces the correct result, it's correct.
So let me ask you, I know how we get values and inputs and outputs. What is a way which this an algorithm could predict a number?
Like a random number?
Yeah, like a random number, do like 1 to 100.
Or so there is a random number. We'll talk about random numbers soon.
The random number generators are very interesting. Have you heard about the Cloudflare's way of creating random numbers?
So we can just say there's a random number, but we'll talk about that soon.
That's really cool.
Because they're not really random, but they're random enough.
They have to have a source of entropy from somewhere.
Yes. They're not true entropic numbers. But even in reality, things that we would there's multiple types of random. That's a big deal in probability. The things that just seem random, like if we're at a store, when is the next customer going to arrive? That's random for all intents and purposes, because we would never do the calculation of every thought running through every person's head that might be coming to our store, and where they're at and what time they're going to arrive. So it seems random, but it is a deterministic thing, versus the radioactive decay. That really is random. We know after so much, if we set a radioactive element out, every so often, one of the atoms in there is going to decay into a smaller element. But we don't know which atom, and there's not really a way to predict it. It is truly random. But for computers, we have that deterministic thing where it's just complicated enough that it's going to seem random for all intents and purposes. Like, when is the next customer going to, or a hospital? That's a good example. When is the next patient going to come into the ER at the hospital? That's a very deterministic thing, right? Because we live in this universe, and the person that gets sick or injured that happens to be the next one heading to the ER, that's the result of a big chain of events that are already in progress. But there's no way that we would ever calculate that chain of events and to do the prediction. So we would always just call that a random value. Yeah, some of them are random. Question in the chat room about casino games, but only so random, right? Roulette would be one of the most random ones. There's a disc surface like a bowl spinning clockwise, and we spin a ball counterclockwise to roll the opposite way around that spinning bowl. So when it comes down to the end, we're not going to predict what number that roulette ball is going to land on, but it's at least theoretically possible to do so. If we knew every trait going in there, like how hard the roulette casino workers spun the ball and how fast they spun the wheel, and
the robot that does that.
Yeah,
perfectly.
Air resistance, the temperature in the casino is going to make a difference there. How dry is it, right? Is it really humid, or is it is it like the casinos here in Indiana, in the Ohio Valley, sitting right on the Ohio River, one of a very, very humid place on earth? Or is it like the casinos in Las Vegas, where everything is really, really dry? Because moisture would make a difference there, but we're never going to determine it. So random gets into stuff like that. But we will see random stuff soon. We will get there, Keegan. Does the if-else structure make sense? Okay,
Yeah.
I assume silence means no questions there. So I'm going to hit save, and then we're also doing this in Python, right? So I wanted to point out that if the visual representations are helping you out, if you're just getting started into programming and you need to do something in Python and switch it to a text one, we do have this generate button where we can generate this code in different languages. Standalone is an executable. That's a .exe file. That's the final version. So that probably wouldn't help us. But some of these others, C++, C#, Visual Basic, those are text-based languages as well, or Ada. That one's not used as much anymore. But if we choose one of these, I'll go with Visual Basic.
Which one does the Python use?
Was Basic your first language?
It's different. Visual Basic evolved from a language called BASIC, which was created by a college professor back in the 60s because it was so complicated to get started that he wanted an easier language for students to work with. So VBA might be close to it. So if we just generate something in VBA.
Is that what Commodore 64s run?
It would run BASIC. It was before Visual Basic.
Okay.
So it looks like this. We get some keywords that we don't necessarily need. It's a strictly typed language. We can ignore that. But then we get down to this. We see that if-else structure. And we can see what it looks like in words to compare it. So there's the VBA one, or Python. uncheck that box. Open that with that. Then here's the C++ one. So you can see there's some extra stuff here. But we get something like this. So it looks a little bit different than Python, but we have some of those keywords. That keyword if, and then the condition. So bits and pieces of this, we can then copy over and work and move between the flow chart and the text one. Since we don't have Python directly, it might not hurt to just generate all of them. Let's see what Ada looks like. Named after Ada Lovelace, who was, you might know her from your literature class, but she was also big here in
I know Lovelace from Home Assistant's dashboard, I think, right?
yeah, she was
Well, no, that was it was called Lovelace, I think, in homage to her.
Victorian nobility. So she was rich and did a bunch of stuff. She just did what she felt like doing. But she was very interested in Charles Babbage's machine when he did the analytical engine. So once again, creating it in the language named after her. So yeah, she did a lot of the programming on that machine and helped get it working. She did some math stuff. She wrote some poems. So I think most people might see some of her poems in high school literature classes, but then she also shows up in math and other places. She did a lot of stuff, computer stuff. You see, there's a lot of similarities when we go over and put this in text. So maybe that would help you do it in Python. I'll just go directly type this in Python so we can see the syntax. And right about now is about the time I thought we were going to be done. So it'll be just a little bit longer than I'd anticipated. But we'll just type this same thing in Python real quick. So I'm going to go to Ripple IT again, which I would most certainly cannot pronounce that repel. I think I've heard other people call it repel. And there's a funny thing about names that if you're created and say people should pronounce it this way, that doesn't necessarily mean people are going to. There's a big deal recently with GIF. There's a big deal recently with stuff from the Raspberry Pi company because they abbreviated Raspberry Pi microcontroller and they wanted it called Pico.
I heard about that.
But that's PICO. And that's one of our metric prefixes. So that's already a word in every language on earth. And it's not pronounced the way they wanted it pronounced. So however you want to pronounce this website, they have an online IDE. They said pronounce it Ripple. So we'll do that same logic here. So I'm going to come over here and copy this. Or the quickest way is just to bring in our pseudocode. So I'll put that in there as a, not a comment, but we can use that like a comment. And we'll kind of do the same thing in Python. We saw how to set variables and get input already. Okay, so score is equal to input, enter the score. But that's a string. It comes from our keyboard, right? That's our symbols. So that's like binary coded decimals. That's the symbol for the number, but we need to actually turn it into a number so that we can do some math with it. And once we have that, we can check our conditions. And in Python, white space matters, so indenting matters. So like if that score is at least a 90, just like we had before, and then we put a colon at the end. Whoops, I did not want that. And then after, then everything we want to happen is indented. So they block off the instructions for the yes part simply by indenting it. And we'll say grade is equal to an A. If it's not that, well, we have that else if situation, but the white space matters, which I'm going to throw an error here to kind of accentuate that. Score is greater than or equal to an 80. I'm going to push space a couple more times. Grade equals B. Because to a human, any human you ask, they would just call both of those lines indented and say there's no difference between them.
I'm internally screaming.
But yeah, this is an example of the biggest problem with Python, the biggest difficulty, because they did that because curly braces and semicolons and the other arbitrary symbols can be hard to keep track of. But
Don't
okay,
give me
we'll address that in a moment, Johnny. There was a question in the chat room, but looking for missing white space is so much harder. When your white space gets off, you have to look for like what's missing there. But do you see the similarity to what we were doing? I'll do the rest of them correctly. So else if, which is abbreviated elif, because our white space matters, so we can't have a two-part keyword. 60. Our grade is, well, still a passing grade, but if it's none of those, there's only one grade left it could be. And then when we're done with that, yeah, so there is an error here. I like to actually throw the error messages and see how to fix them instead of just telling y'all how to avoid them, how to spot them and know what they mean. Then when we're done with that, we'll just print the output. The grade is plus what we found the grade was. See how in the two separate things, it's very similar, whether we have the pictorial representation, which we can generate some text-based code off of it. It's unfortunately not the text-based code we need this semester, but a lot of those symbols are similar and stuff. So that can help you make that transition. Then we'll do all those else if comparisons until we find the one it is, and then do the output. So we'll run that, and I want to go into B. So let's say it's 83. We enter. We didn't throw the error. Okay, so this is apparently automatically fixing stuff. Let me run this somewhere that won't automatically fix it. I have idle on here. Yep. So on the nice fancy one here, it looks like they automatically fixed it. So let me just put this somewhere that won't automatically fix it. There you go. Notice that it's at a different level. So I'll run. Sure, save it.
Are we on the Python assignment?
It was just sort of a random Python thing.
Oh, okay.
So kind of the same thing we just saw, Keegan. So we'll enter a score. Say
Yeah,
80.
sorry, my computer just died, so I just did not know what we were doing. Like during that time. Yeah, my computer was dead.
Okay. Yeah, so it's being recorded. You'll be able to come back and check it. Okay, yeah, I
Okay.
don't know why this is automatically fixing this. This should be thrown. I was expecting an error. What if I go down here? Maybe I need 2 lines. So let's say oh, that's why. Sorry, just making some adjustments to the code so y'all can see the problem here. be and this throw the error.
Like you're trying to break it and it's not wanting to break.
Yes. I'll just throw another random line in. Let's see if this does it. Okay, there we go. This is the error message I was looking for. You will see this unexpected indent or indentation error. And when you see those indentation errors, that means your white space got off. Tries to run that. So whenever that happens in Python, the best thing to do is let the computer fix the white space. So like hit backspace and then hit enter once and be very careful about whether you tab over or push space several times, because tab and space do not count as the same thing. They look the same to a human, but they are very different things. You can see the program still runs the same way. We can make those choices. So like 97 in A, and it's like asking questions. So when you're putting your algorithms together, think about asking the question, is the score bigger than 90? And just remember what your keyword is. So for Python, as long as you're consistent, as long as you do the same thing every time, the question popped up in the chat room, would it be best just to hit tab? What the developers of Python recommended, the official recommendation is 4 spaces. Hit spacebar 4 times. But as long as you're consistent, as long as you use tab every time, it'll be okay. If you use tab sometimes and then 4 spaces other times, you can't mix and match it. You can use one or the other, but you can use both of them, but not together. The official recommendation from Python is to use 4 spaces though. And notice when I put my cursor here, looks like this one only went over 2 spaces, but I can scroll through there and see that that is spacing, not a tab. So I come up here and hit tab. Oh, it looks like their tab key just does that. That's probably why I wasn't throwing the error. They have it fixed. Some of our text editors do distinguish between those, and we can define what the tab key means and stuff, but you just want to be consistent with it. Do those things there at the end make sense? You see how it goes together is the flow chart, and if you need it in the text-based one, if you're just starting out, you can just generate that text, not in the Python, but text that would be similar to Python, then you can pull the key parts you need out of that. Might help make that transition.
All righty.
All right, so that went a little longer than I anticipated. Hopefully this is the last 2 break day. For the plan for the rest of the semester does not have any other days where we'll hit 2 breaks. And we'll have a lot more lab time. So but the trade-off for that front heavy content is we have more time to do the fun part when we're making our projects at the end of the semester. We're gonna make sure there's plenty of time for that.
Well, bye. I'm leaving. So
I thought it was good. Thank you.
bye, everybody.
So if there's no questions, I guess that'll be it for today, and we'll pick up from there on Wednesday.
All right, I'll see you at Computer Club tomorrow.
Yeah.
I might not be in the school, but I'll be in the Zoom meeting.
Okay, I'll see you then.
All right.
I got like 2 questions.
Okay, should I keep the recording going, Johnny?
Oh, it doesn't matter.
Okay, I'm gonna go ahead and stop the recording.
Yeah, okay. The first